Oh, that's so
Genius.
nice. Oh, there we go.
Yeah, that looks pretty good. Dr. Moore, how are you today?
Doing okay, yeah. Just, we might have a place for my mother-in-law, which would be nice. So, yeah, that's, her Alzheimer's is advanced to where we can no longer really safely take care of her, so.
Yeah.
But with COVID, there just hasn't been any openings in many places. So it seems like that may happen, which is
A little bit of a relief.
a little bit of a relief. Okay, let me pass these back since you guys are here, as people come, we'll see if they, Christian, Zach, if I can butcher your name, just with Sanford, Joaquin, sorry, Joaquin. Garrett, James, Steve, Laney. This is the way I learned so many names, is by handing stuff back. I just haven't had that gift. Jonathan, Zach Obrecht, Christopher Mashburn, is that right? There it is. Julia. Miles.
Thanks.
Griffin. Michael. Avalon. Aiden. Jonathan. Henry's. Jason. Alex.
Yeah.
Alex. Kyle. Parker. Thomas. Shay. KN. Christian. Zach.
Which one?
Sorry, Zach Gafford? Garrett. Steve Shelton. Jonathan. Zach Ober. How do you say your last name, Zach?
Ober.
Obrick?
Yeah.
All right, thanks. There you go. Julia. Griffin. Michael. Aiden. Jonathan. Henry. Thomas. Did I give you your straight yet? Maybe it's back here.
I don't know where yours is at.
This is Zach.
Zach's there, okay, Zach. Did you send it to me by,
Oh, no, I was in class.
you were in class? Okay. There it is. I've never lost a student's test, and I started teaching in 1984. So but it's surprising, given who I am. Okay, Thomas.
I got you.
Oh, there you go, Thomas, thanks. Parker. There you go, Parker. Jonathan. Aiden. Michael.
Yeah, what do you reckon?
Griffin.
Yeah.
Good point.
Julia.
But you're gonna write me through all around.
Jonathan. Steven.
It didn't work. I went back.
Okay, guys, let's talk about these. In general, it was just about where my historical average was, which is pretty good given the fact that we've been online, which is pretty good given everything we had. The average out of 100 was a minus 28 or a 72. The average out of 100, so like the average on the Quest was like a minus 14, roughly a minus 14. So that gives you some sense of where it's at. The high score out of 50, I think was a minus 3. The high score out of 50 was a minus 3. And I think that was followed by a minus 3.5, followed by a minus 3.5. So that gives you an idea of where you're at. It's the first time that you guys have had, a handwritten test in a while. True or false? You know, so, yeah, and for some of you haven't had math in a while, so I mean, it's a double whammy having both of those. So, in lieu of that, I probably shouldn't, 72 is a fine average, but I decided to give you back 20% of what you missed. So let's just say somebody was average and had the minus 14 out of 50, they would get back 20%, this is calculus, 0.2 times that 14. So they would get back that point. So their score would be 50 minus 14, which is 36, and then plus the 0.2 times the 14. Does that make sense? And I think that brought that average up to about a 77 or 78, which I think is fine. I mean, typically my average sits around 74 or so. But I felt like, you know, the fact that you guys hadn't had anything in your hands in a while, and I don't want you guys to get out because you're gonna come back, some of you your junior year, and you're gonna get hit like a freight train of stuff when everything's back where you're in a classroom just taking tests, so. So in general, I was pleased. Some of you, I mean, it's called a quest. When we test something, why do we test stuff?
To improve.
To improve, that's right. We want to see where we test the space shuttle before we fire the space shuttle, right? Isn't that what we should do? Isn't that what we should do? We test things before we fire them. I typically consider blast off my final exam. I've never had a semester where I haven't given final exams in every cumulative finals in every one of my classes, because that gives me exit knowledge on what kids are leaving with. Except this semester. This will be the first time ever I don't give a cumulative final exam, just because it is COVID. It is COVID, and you guys are dealing with a lot. You don't really know how much you're dealing with. It's only going to be like when it's all done and you're looking back and you're trying to process what this has been. Then it will hit you like, oh wow, that was a lot more than. I mean, this is the most social time of your life, right? I mean, it's genetically built into you. You're just drawn to be social. It's almost impossible not to be. And yet everybody's telling you it's dangerous. And yet it's not so dangerous to you. You know what I mean? It's like you're dangerous to everybody else. And so you're just carrying a ton of stuff. So yeah. Classes don't matter. I'm filming. Classes don't matter. I mean, everything else doesn't really matter. Remember, an entire semester of 0.0, and again, I'm filming. Okay, and I'm still your college professor. I'm still your college professor. Okay, but it maybe does point to some areas where, like, Dr. Warren, I don't understand what I'm doing here. What I'm not doing. And for a lot of the problems, it's algebra. I mean, it's algebra, and you know it's algebra. I mean, it's not so much you don't understand the flashcards or you don't understand things. It's algebra, you know. And so getting remediation with that, some basic things will help. And then having the flashcards down. I'm hoping the more we're in class, I just wish, like I said, if you want to come, I mean, I've got 22 chairs up in that room. If you want to come, you're like, Dr. Warren, if it was me, Zoom, I'd be so distracted. The last thing I'd be able to do is like, oh, this is blurry. I'm not doing this. Check. You know, I mean, especially when I was in college. But, you know, so if you want to come every day, I'm almost certain there'll be a seat. If you're like, I'm better. Some of you are so ADD, you need to be right here, okay? I needed freaking horse blinders, and you know, like the Amish, they put on their horses. That would have helped me the most, but I just didn't want to, I wanted to date people, so I didn't think wearing horse blinders was probably the way to go. Okay, let's stand up. Stretch, don't breathe on people. I'm not quite sure how they put the X's in this room, but nobody looks that far apart. Okay, let's sit back down. We will likely have our third quest next week. We'll likely have next Friday, same bat time, same bat channel, right here, okay? We'll probably have our third quest next week. What did I just say? And I'll talk more on Monday about which sections. Kind of depends a little bit on what. But you know at least it's going to be product rule. At least you know it's going to be product rule, and chain rule. Product rule, chain rule, and then maybe a little bit of the definition of the derivative. But we'll see. Okay. We were talking about what for like last class and a half? We were talking about what? What has that been focused on? Let's see what actually settled in your gray matter. Power chain rule. We did some of that. Rates of change. Yeah, well, King's like it's rates of change. And so does it make sense that would be important?
Yes.
How one quantity changes with respect to another quantity. Does that seem like that would be important?
Yeah.
Okay. We found that we could make up silly. Units, and it's still we could come up with stuff. Like for example, if something was if the domain variable for the function was x, okay. How about units?
Domain.
Domain, yeah. Okay. What units do you guys want for your
Peanut
domain?
butter
Oh,
pie.
meters.
What was that, Alex?
Peanut butter pie.
Peanut butter pie?
Yeah, like
Okay.
in D-Hall.
Yeah, exactly.
I'll do that.
Yeah, I have like 5,000 punches to D-Hall, I have, because like faculty can buy them, and it ends up being like $6 a meal, I'm like, that's not bad, I should do that. I haven't gone to D-Hall once this year, I'm just like, I like looked in the windows there, and I was like, no, I'm not going there. I'm not going anywhere near that place. Okay, peanut butter pies, that's what's going into the function. And what's coming out of the function? I got peanut butter pies are going in.
Pounds. Pounds.
Pounds,
Wait.
okay, all right.
Worth it though. What?
I know this is gonna somehow be politically incorrect. I just know somehow I'm gonna be thrown under the bus by my daughters for using this, okay? So we got peanut butter pies, and what's coming out of the function, the range is pounds. So like, for example, if I say f of 2 equals 5, interpret that for me. F of 2 equals 5, interpret that for me. Turn that math into English for this model.
Peanut butter pies equals 5 pounds.
Yeah, 2 peanut butter pies equals 5 pounds. 2
You'd be
peanut butter
correct.
pies equals 5 pounds. So what's going in is pies. What's coming out is pounds. Now if I say f prime of 2 equals 1, is that going to have a different interpretation than what we're saying right here? If I say f prime of 2 equals 1, is this going to have a different interpretation than pies and pounds? Is that going to have a different interpretation? And the answer is yes. How many people are pretty comfortable turning that into English? How many people are pretty comfortable turning that? It's this where it becomes more of an issue. And that's what I want you guys to be able to do. I want you to be able to turn the mathematics into English, in case you have to explain it to your boss. Okay, so let's first of all figure out the units. I love having these boards broken down. I feel like I'm really powerful. What about that? This is some good teaching here. Peanut butter pies, pounds. My colleagues would be horrified. So I'll bring this down. Okay, let's think about f prime of 2. What's the definition of that? Like, what the hell, Dr. What's the definition of f prime of 2? And this is where kids just don't get it. They don't get the importance of knowing the definitions. What's the definition of f prime of 2?
The derivative of f2.
The derivative of f at 2, I like that. Now, what's the definition? Math is proof. Calculus is about limits, derivatives, and integrals. Oh my! Everything's defined in terms of a function. I like that. And in calculus, and a limit. Good. Let's try that again. La la la. When I go la la la, you say
Limit.
La la la.
Limit.
Everything's defined in calculus in terms of a
Limit.
limit. So if I'm looking here, it would be the limit as, now you guys help me out, the limit as x approaches 2. F of 2 is hanging out over here.
F of x.
F of x. We have one of those. And then what's in the bottom? What's in the bottom? X minus 2. And it's in the definition that we can get the units. It's in the definition that we can get the words. If I look here, x and 2, are they coming from the domain or the range? X and 2, are they coming from the domain or the range? The domain. So what are the units of the denominator? Pies. Now, what's coming out of the function? Pounds. So what are the units of the f of x and the f of 2? Pounds. And so here we can see the rate. It's a rate measuring how the pounds are changing. The weight is changing with respect to the number of pies. Now the next thing when I'm looking at this, is this one positive or negative? Positive. So when it's positive in a derivative, you're always using the word increasing. Write that down. if the derivative is positive, you're using the word increasing. Now, I know, if the derivative is negative, just guess. If the derivative is negative, what do you think you're gonna use?
Decrease.
Decreasing, so write that down. Okay, the next thing I want you to notice this is the number, and everybody should know this. Except that, like, if we're zooming, then you're like, Dr. Warren, I don't really see that at all. It's awfully blurry. How nice is it to actually be able to see? I mean, isn't it nice to actually just be able to see? This is 2 pies. This is 2 pies. It's still x. So this we understand. This is the way we interpret this. We say at 2, and again, these are at 2 pies. The pounds of weight, I'll just use this, is, and now what did I say? If it's positive, what word do you use? What word do you use if it's positive? Increasing. At a rate of, and then now we come over here and we look, well, what was the rate? It was 1. At 1 pound per pod, at 1 pound per pod. The rate of 1 pound per pod. How do you think they can do that? How many people think I could give you a scenario and you could maybe come up with something like that? Now suppose this was not 1, but suppose it was 100. Suppose it was 100. Then what's the only thing that's going to change? What's the only thing that's going to change? Well, now suddenly it's going to be, the rate is going to be 100 pounds per pie. Would you eat the next freaking pie?
No.
Would you eat the next pie? Probably, and what does the model predict's going to happen? It predicts that you would gain 100 pounds, right? I mean, you're like, oh, okay, well, maybe I shouldn't do that. Maybe I should just miss that pot. You're like, well, Dr. Warren, when we had two, it was only 5 pounds, okay? It's clearly not a linear model. It's clearly not a linear model. It's going to be a quadratic. It also looks kind of like exponential. Like, oh my gosh, could you imagine if f prime of 3 was 1,000? If f prime of 3, because that would be saying at 3 pies, the rate would be increasing at a rate of 1,000 pounds per pie. 1,000 pounds per pie.
A lot.
Okay, so now, give me a function. Give me a function. Give me a function. Give me a function.
You're right, you're right.
Give me a function. Give me a function. Give me a function. I'll keep going. Give me a function, my students.
X squared
Right, I'm stopping this now.
plus 4x.
Plus 15.
Jesus Christ.
That's what you're measuring these in?
We're really going for it.
Okay, well, we're gonna come up with a different scenario. Okay, yeah, we're done with our politically incorrect scenario. Miles, okay, you get to pick the domain units.
The units.
What are the domain units?
Pencils.
Pencils, okay.
Dr. Warren, that would be the freshman 15 though.
Okay. Thank you, Barry, for just throwing me more under the bus. Okay, okay, now what's coming out of the function? What's your range? Pencils are going in. Pencils are going in. What's coming out of the function? Erasers?
Eraser shavings.
Eraser shavings, okay, so maybe,
Pencil sharpeners.
how about blood? How about blood?
Okay, I don't know if you can blame us for throwing you under the bus?
I guess that's true. I've kind of lived my whole life under the bus. I'm filming this. Okay.
Ounces.
Ounces of blood. Okay, so yeah, so we're throwing pencils at people, and we're seeing how many ounces of blood we can draw. So it's Halloween, right? Might as well go with this like a slasher movie. Okay, so yeah, Jason is now drawn for pencils. Okay, so now you guys find f of 2. You guys find f of 2. And Henry, what did you get? Did you get a number?
I got 27.
Did anybody else get 27? Anybody else get 27? Okay, so now interpret this for me, Lorelai. Interpret this for me. What is this saying? Interpret this for me.
Jason uses 2 pencils and gets 27 ounces of blood.
Perfect, Lorelai. Say that again.
Jason uses 2 pencils and gets 27 ounces of blood.
So now to keep it consistent for this class, we'll just say at 2 pencils. At 2 pencils, we get 27 ounces of blood in our horror movie. So now find f prime of 2. Find f prime of 2. This is going to require a double move. You have to take the derivative, and you have to evaluate it. I'm kind of hoping like on a quest you would be done. I'm kind of hoping on a quest you would. Does anybody have f prime of 2 for me? Does anybody have f prime of 2? Anybody get the numerical value? And what do we have? 8. Okay, did anybody else get 8? Did anybody else get 8? Okay, now I'm not going to do this, you're going to do this. Put the units beside the 8. What are the units in our horror model? Measuring for that derivative. What are the units of that 8? I can't wait. Trey, do you have any units for me?
Like ounces over pencils.
Ounces over pencils. Did anybody else have ounces over pencils? So this is, we would probably, usually they make that denominator singular. Usually when you're interpreting it, but it's exactly right, Trey. It's ounces per pencils, but we usually say ounces per pencil. So now, interpret this for me. Let's turn this into English. Again, we're going to use the word at 2 pencils. The ounces of blood is increasing, positive, negative, is increasing. Since it's a derivative, it's going to be a rate, at a rate of
8 ounces per pencil.
8 ounces per pencil.
It's like 2 pencils of a whole.
So yeah, this is our. And the other reason I think about this, my daughter works in film. I have 5, so this was number 2. She works in film. She's right now in Czechoslovakia working on Marvel stuff. She worked on Ant-Man 2. She does specialty costuming, but she also worked on The Walking Dead. And she would always tell me about the fake blood and everything like that they would have, and how she's like they fly her first class, so she's there first class, And she's there, and they're like, well, what are you gonna do when you get where you're going? She goes, well, I'm gonna take all these new clothes and make them look like old clothes. They're like, that's what you do? And she's like, yeah, that's what I do. So yeah, fake blood, fake blood. How many people are kind of getting it? How many people are kind of getting it? Do you guys get, like, we can almost, just give me any scenario and we can do this game. Okay. Stand up, stand up, stand up, don't breathe. Sit back down. There's nothing exciting coming, so I'm just letting you know, don't get your hopes up. Okay, so I just thought I'd pull up a couple of things. I thought this is kind of fun here. This is like, can you read what that says? Can you read what that says?
Inflation adjusted oil prices.
And we see, so this has already been adjusted for inflation. But you can see, like, from 1919 to like 1969, oil prices remained reasonably, yeah, pretty steady, almost constant if I'm looking at that. And then in 69, what happened?
Oil prices.
Yeah, they went up. Does anybody remember, or does anybody know remember, like, you guys were like -40, okay? But does anybody know historically what took place then?
Big energy crisis.
Big energy crisis. OPEC started shutting the valves to drive up prices. Did it work? Did it work? So I was born in 61. And in this period of time, gas was 33 cents a gallon. Gas was like 33 cents a gallon. So that's adjusted. It was like $20 a barrel adjusted time. And then within a year, it went to almost $1 a gallon. So it almost tripled in price. Now imagine right now, I mean, gas is roughly hovering at $2 a gallon. Is that a pretty good price for gas? I mean, when you think about your parents, what they filled up with. I mean, right now, it should probably be about $3 a gallon. But imagine it going to $9 a gallon. That's what was taking place over this point in time. And then you can see when Reagan took over, but it really started before with Carter. You see what's happening with the oil prices. They're beginning to jump down, and then they started going way back up when you guys started driving. It's all your fault, okay? And then suddenly they started coming back down, and it's been steadily going down. And I'm not sure I'd buy oil. I'm really not sure I'd buy oil right now, just because a lot of the stuff that we're thinking about GM and a lot of the places, a lot of the stuff's going electric. And I really see that being one of the driving manufacturing booms in this country. My one son-in-law works putting in those essentially electric gas stations where you have those chargers, and she just says it's a train wreck. That's what he says. It's a train wreck right now. So there's one graph. There's one graph. Okay, I thought this is a fun one. This is the graph of airline stocks. Over this year. So yeah, you're looking there, okay, and then you see, thought that was fun. I hate the airlines industry. Yeah. Okay, and this is maybe not as fun. This is COVID. And we can see lots of kind of interesting graphs. I'm not sure what any of them mean. Because I don't think anybody does. But do you guys think, like, knowing when you've got a model of something, do you think, like, knowing when it's increasing and decreasing is important? I mean, in all of these models, if it's somebody's job to analyze it, do you think knowing when it's increasing and decreasing is an important thing to be able to do?
Yes.
Okay, so that's kind of my motivation to get this new chapter started. We've essentially finished chapter 3, and now we're moving into chapter 4. Now, in the old days, I'd say take out your books. But like, what the hell? Okay, I'm not carrying that thing. I didn't even buy it. Chapter 4 is called Applications of the Derivative. What's it called?
Applications of the derivative.
Okay. Now, how many of you guys are really good at plotting without a calculator? How many of you guys love to plot functions? Look around the room. Just look around the room, okay? How many people like drinking beer? I don't want to know. Don't close your mind. How many people like graphing functions? Do you think there's more people in the room that like drinking beer than graphing functions?
Yes.
Okay, so I would probably bet that too. And the biggest problem with graphing functions is that the more complicated they get, the more of a challenge they are to graph accurately. And I really am not convinced that graphing is as important as it used to be. It's hard for you to believe the first programmable computer, the first electric computer, ran its first program about the same time your grandparents were born. So everything we understand about technology has happened in one person's lifetime. When I was in school, a handheld calculator that did addition, subtraction, multiplication, and division cost $400. $400. And then, like, my dad had one that did square root. He's a doctor, you know. Like he ever used square root.
Yeah.
You know, I'm just like, seriously? Okay, but he had to have the new toy, you know. It was like $400. And an LED screen, and it was red LED. A new car, a new Chevy, not a nice car, a Chevy, sorry if you have a Chevy. Okay, a new Chevy was about $5,000. A new Chevy at that time was about $5,000. Okay, that gives you some sense. When you tell your grandkids that you spent $700, okay, you wouldn't. You tell your grandkids that your parents spent $700 on this, they'll think they're out of your mind. You know, well, we just get those in vending machines now. iPhone. Okay. This will cost, I tell you right now, this will cost under $100 probably in the next 10 years. Technology changes. And I knew I was heading somewhere with this story.
Graphing.
Oh, graphing, thank you. All right, yes, bless you.
Applications of the derivative.
Applications of the derivative, increasing, decreasing. Yeah, I mean, I don't think graphing is important. I do think graphing is important. I'm filming this.
For the record.
It's not as, yeah, for the record, okay, but it's not as important as it used to be. How many people recognize they can get on a computer anytime, any place, and probably get a graph of a
It's called
function from you?
Desmos. Okay.
It's called what?
Desmos.
Desmos?
It's a
Okay.
graphing
Look
calculator
at it, it's
online.
fun.
Okay,
You
that's
love
good.
it.
Yeah, I'm sure Desmos was going on all the online tests. Where's my Desmos?
You didn't have to plot anything.
Okay, Wolfram Alpha is another site. Yeah, Wolfram Alpha is another site that'll take derivatives for you and integrals, anything in this class. Okay. Sorry. Why do you think you're taking tests in here? I know how tempting it would be. Everybody else is doing it. They're gonna have an advantage. What would one look hurt? It's like heroin, right? I mean, not even the same thing.
What is just one injection of heroin?
I'm just saying, like anything bad. It just seems like, oh, just a little bit won't hurt.
Ah.
Never do heroin. I'm not joking. Never cheat on a test.
We went from like graphing
I'm not joking.
calculators to heroin.
Yes, no, this is my life. Imagine me living with this. Imagine being raised by it. Okay, my point is this, that graphing isn't quite as important as it used to be because it's pretty easy to get a plot. It's pretty easy to copy and paste that plot and put it into any document that you want. But also the plotting is somewhat challenging. And that you don't want to have to plot everything to try to figure out when your mathematical model is increasing or decreasing. You don't want to have to rely on that. We want to have algebraic skills to help us determine when a function's increasing and decreasing. Like, for example, I could ask this, I could look at that function right there, and I could say plot it without a calculator and be like, no, I'm not doing that. I don't think I'm gonna do that, Dr. Warren. I don't think I'm gonna do that. I could ask, when is it increasing and when is it decreasing? I could ask, when is it increasing and when is it decreasing? Might that be important in this horror model? Would that be
Yeah.
important?
Yeah.
Okay, to know when the amount of blood is increasing with the number of pencils or decreasing with the number of pencils, which doesn't make much sense. Okay, and that's one of the major tools that calculus gives you. What did I just say? Other than the heroin. One of the tools that calculus gives us, if you can take the derivative of a function, you can determine, it takes a little bit of effort, but you can determine when the function is increasing or decreasing. Okay, and that's kind of what I'm motivating to try to, before I start dragging you through why. Math is hard, no. Math is proof. Math is
Proof.
Math is
Proof.
Okay, so now, let me try to justify this for you. Suppose I've got some number in the domain, like 3. Okay, and I know that f prime of 3 is 7. And I'm trying to understand a little bit about what this might mean. We've talked about it, turning it into language, but I want to talk about like increasing and decreasing. And so, since math is proof, we're going to need a definition for what it means for a function to be increasing. And so that's going to be the first thing we're going to put on the board. Definition. F increases on a closed interval a to b. This is going to be my first definition. F increases on an interval a to b. Okay, I'm going to get lazy on you guys, and I'm going to use this expression. It's IFF. It's IFF, and it doesn't mean if. It means if and only if. It means if and only if. So anytime you see IFF in this class, you say if and only if. What did I just write? What did I just write? For all, now you're going to get angry with me. I'm using subscripts. Oh, Dr. Warren. For all x1 and x2. Now let's just read it. Let's just read it. For all x1 and x2 that are elements of the closed interval a to b. So let's read at least where we're at right now with our definition. Definition. This is laziness for definition. F increases on the Okay, now I'm going to get lazy on you again. S dot T dot. Such that. This stuff will make you, I mean, I can show you some other stuff that even make your parents more impressed. Okay, you wouldn't even need to tell them. They just look at your math and think, oh, I never understand that. You don't have to tell them this means if and only if. Okay, you don't even have to tell them this means element of, or that this means such that. So read where we're at again. Read where we're at again. Such that. Read that. Okay. Now, this is the logically follows. It logically implies. And actually, in math, put an less than or equal to here. It's a little annoying. I don't know quite why they do it, but it's historically what's come down. Okay, so now let's try reading the definition again. And some of you guys just need, stand up, I can tell already. Some of y'all, I can just see, I can sense the boredom going around the room. Okay, don't give yourself COVID, just slap yourself in the face. Don't give yourself COVID.
Say, wake up. It's Friday.
It's Friday.
Friday.
It's close to Halloween.
It's close to Halloween.
Okay, let's back down.
Yeah, I don't wanna see the COVID dashboard after next weekend. I don't wanna see the COVID dashboard after next weekend. Okay, so now let's read this one last time,
Definition of increases on the closed interval if and only if F
For all x1 and x2 that are elements of the closed interval AB, such that must logically follow that f of x1 is less than or equal to f of x2. That's the definition. Where do definitions show up on Dr. Warren's quest as I try to get you ready?
True or false?
In the true or false, in the true or false. Warning, warning, warning. We have a quest, Lynn? Okay, so now what I want you to do is, I want to show you this definition actually makes sense. Like Dr. Warren, I can't even freaking read it. I don't want to draw an XY axis. Draw an XY axis. And just draw a function that to you seems like it should be increasing. Draw a function to you that seems like it should be increasing. Okay, now we're just gonna try to use the definition. Mark an A and a B. Mark an A and a B, and an A should be less than B. There, it represents the domain. It's kind of the domain that you're using. Now, pick an x1 and an x2 in the domain. Pick an x1 and an x2 between A and B that satisfy that x1's less than x2. In that domain, pick an x1 and an x2 that satisfy that condition that after the such that. So now we have most of the definition on the board, right? I mean, we've got ourselves a function. We've got ourselves x1 and x2. We got our domain. Now, if it's increasing, if your concept of increasing is right, then the range values, it should follow that the range value, f of x1, has to be less than or equal to f of x2. So mark f of x1 on your graph and mark f of x2 on your graph. Mark f of x1 on your graph and mark f of x2 on your graph. And so now what I want you to do is just share your graph with somebody else. Show. I mean, don't breathe on them at all, but share your graph with somebody else. Show somebody else what you've got for your graph.
I got you.
Yeah.
Is this wrong?
I can see it, it looks good.
Okay, now I've just shown up in the classroom, and you're gonna tell me what I told you to do. Dr. Warren, what'd you just say? I just showed up in the classroom, and you're gonna tell me to do what I just told you to do. What was the first thing I told you to do? Okay, so I do that.
Draw an increasing function.
Draw an increasing function.
Anyone
So I got that.
Draw an A and a B.
A and a B down here in my domain. Then pick a,
X1 and X2.
and I know I want down here in the domain x1 to be less than x2. And then what did I ask you to do?
Mark f of x1 and x.
And remember, in this game, most kids from high school don't come in doing this right. You come up and go over, and that would be. Then I come up and go over, and I get. Did it work? Did it work? Did it work? Did it work? Did it meet the definition? Did it meet the definition? Okay, so my less than here is with respect to which axis? My less than here is with respect to which axis? Yeah, and my less than here is with respect to which axis? Y axis. Now, if I take any other x1 and x2, like maybe I make this guy x1 and I make this guy x2, would it still work? Would it still work? So does the definition kind of make sense why it is the definition?
Yes.
Miles?
This only works for like positive graphs though, right?
It only works for increasing graphs. It only works for increasing graphs. So even if it was like, I know that even if it was down here,
It still works.
it would still work, because I have this guy and that guy, and this guy would still be less than that guy.
Yeah.
Okay, that's the definition. That's the definition of what it means to be increasing. Did you just feel the boredom? I felt the boredom go through the room. Did you guys, anybody else feel the boredom? Did you guys feel that? I mean, I just felt the boredom go right through the room.
I mean, I heard something sweet, was that it?
See, I even brought heroin in, and nobody, sorry, I didn't really, I didn't really bring heroin in. I just brought it in metaphorically into the room. And I don't even think it was a metaphor. I don't even know. Okay, back to where we were. Suppose I've got f prime of 3 is 7. And I want to show you how this, in a small way, meets the definition of increasing. You're like, well, Dr. Warren, how could you do that? This just says, read it. F prime of 3 is equal to 7. Well, we've got to remember the definition. What does f prime of 3? What is the definition of f prime of 3? And what did we say that limit's going to be equal to, guys? What number is equal to 7? Now again, if it's somebody who doesn't know this, and this is what happens with the AP calculuses, the students end up getting prepared to take a multiple choice test, but they don't get enough of a foundation to do anything more than take a multiple choice test. Okay, so now, here's my 3. Here's my 3. I'm taking a limit. Now this probably you've forgotten already. A limit exists if and only if the limit from the left equals the limit from the right. And we're saying the limit does exist. The limit does exist. It's 7. So the limit from the left would also have to be, and the limit from the right would also have to be. So now imagine that I pick an x close to 3, but on this side of 3. Imagine that I pick an x close to 3, but on this side is 3. So I assume that I'm close enough now where this, I don't really want to talk about the limit, but I'm close enough where this fraction is close to 7. It's close to 7. I don't want to deal with equality anymore. I don't want to deal with the limit, but I'm saying I'm picking x close enough where this will actually go to 7. The left-handed limit must exist. More importantly, is 7 positive or negative? Is 7 positive or negative? Positive. Now you're going to have children one day, okay? Like that one I'm not. Like I said, I didn't think so either, but I have 5. 5 college educations. I got 6. I've been doing this for 20 years, college, not teaching college educations. Pay. And guess who I pay? 3 of them went to JMU. I'm paying JMU the same money your parents pay. I don't get a break. I pay the same money your parents pay to send my kids to the school I teach at. That's how much I believe in the school. Yeah, no. I believe in this place. I really do. I mean, I support it. How many times have you seen me in a Madison shirt? Every day. Not the finest Madison shirt. Don't buy me anything nice. Okay. No. It's not good. I break everything. Like this lecture. Okay. Since the limit from the left exists, I'm going to get close enough where this will be close to 7. More importantly, it's positive. Now, when you're teaching your kids and you got a fraction, a negative divided by a negative is a positive. A positive divided by a positive is a positive. Positive divided by a negative is a negative. Negative divided by positive is a negative. So if I'm looking here, and I don't know why, no wonder everybody looks so confused. Like I said, like I said, I was breaking the lecture. That should be a 3.
What about the top?
So the top one should be three?
Oof, I was so confused.
Here's what you should just say, come on, grab the chalk. Sorry, sorry. What is the definition of f prime of c? X approaches c, f of x minus f of c divided by x minus c. I'm gonna give everybody COVID. I'm gonna be like, we're chanting out. Okay. No. Okay. Good. Sorry, I didn't take my meds. Okay. F of x minus f of 3 over x minus 3. Now I'm on this side. I'm on this side of 3. So would x minus 3 be positive or negative? If you're on this side of 3, would x minus 3 be positive or negative?
Negative.
It's going to be negative, right? It's smaller than 3. So if I'm in this scenario where x is close to 3, Mason, what did I say? I'm sorry. X is close to 3, but not 3. Then the denominator would be negative. But the whole fraction is positive. So the numerator also has to be negative. I'm in this situation where x is less than 3, but close to 3. So this is negative, but that's going to force f of x minus f of 3 to be negative. This guy's going to also have to be negative. What's another way of saying something's negative?
Decreasing.
Not quite, but I like the idea. What's another way of saying something's negative?
Less than 0.
Doesn't that make sense? Less than 0.
Okay, Alex.
Less than 0. Does that make sense?
Yes.
So let's write that down. We would say f of x minus f of 3 is less than 0. Now what if I took this guy to the other side? Could I do that? Could I take that minus f of 3 to the other side? Could I take this minus f of 3 to the other side? And when I did that, what would happen? It would become a positive. So this would imply that f of x is less than f of 3. So Dr. One, what the hell are you doing? Well, I'm saying, if the derivative is 7, does this limit have to exist? Does this limit have to exist? And is it not the number 7?
Yes.
Then I'm saying, okay, suppose I'm in the scenario where x is less than 3, but close to 3, where this is close to 7. Is this positive? Is this positive? Like, Dr. One, I don't know anymore. 7, is it positive?
Yeah.
If I'm less than 3, will x minus 3 be negative? Then this will have to be negative, which is the same thing as saying it's
Less than 0.
yeah, Alex, less than 0, sorry. Decreasing means like going down. It's good, but I know you mean this. Less than 0. Does this mean this? Does this mean this? Does this mean this? No, I thought, what are you saying here? Well, okay, we showed this, that if x is less than 3, that f of x has to be less than f of 3. Do you see anything like that over here? Do you see anything like that over here? Yeah. So we're saying that if f prime of 3 is 7 and x is close to 3 on the left, it's meeting the definition of increasing. It's meeting the definition of increasing. You're like, well, Dr. One, that's the left, man. That's the left. There's another side called the right. So if I did this again, it's still 7. It's still 7. I don't know why I erased that. Here's 3, but let's pick it on the right. The limit from the right exists. But now suddenly, is x bigger than 3 or is x less than 3? Bigger, so now I'm in this situation where 3 is less than x, where 3 is less than x. The limit from the right still exists. X is close enough to 3 where this is still close enough to 7. Is 7 still positive? Is 7 still positive? Yes. But x minus 3 now in this case ain't negative anymore. X minus 3 is positive. Then the numerator, if the denominator is positive and the whole fraction is positive, then the numerator also has to be positive. What's another way of saying something's positive? F of x minus f of 3 is greater than 0, which implies that f of x is, just do the algebra, f of x is greater than f of 3, and I guess I'll write it this way, f of 3 is less than f of x. And so in this other case, we have 3 is less than x, implies f of 3 is less than f of x. Whether we're on the left or we're on the right, guys, is this set up just like this? Is this set up just like this? I mean, look back over here. Is this set up just like this?
Yes.
So what we see is that if the derivative is positive at 3, there's some interval around 3 where the function is, there's some interval around 3, and this is where Alex's word's going to come in, not decreasing but increasing. If the derivative is positive at 3, there's an interval around 3 where the function is increasing. And so write this down. If the derivative is positive on an interval, not just at one point, but if the derivative is positive on an interval, then the function is increasing on the interval. And so what this does is it takes away the graphing. If we can just determine when a function's derivative is positive, then the function has to be, if the function's derivative is positive on an interval, then the function has to be increasing. Similarly, if the function's derivative is negative on an interval, then the function is decreasing. If the function's derivative is 0 on an interval, then it's not increasing or decreasing, which would mean it would be constant. So, oh my gosh, you guys didn't stop me? I kept you guys late.
We were learning.
Oh no, but you guys, I mean, I could have gotten rid of all the heroin and all the other stuff and finished on time. Sorry guys, just throw a look at me. I'm just